Okay, let's prove it. So, reminder, finite normal extension, characteristic 0, G is the Galois group, FG star dagger, or as before. Let's go through these one by one. Since L over K is a finite normal extension, we already proved one. The collection of all automorphisms of L over K is precisely the order of the Galois group. So 1 was done. This was done in chapter 11. All right, 2. Star and dagger are mutually inverse and set up an order reversing bijection between F and G. It's contravariant. Okay, so let's go ahead and prove that. So let's suppose that M is in F. Okay, so it's a field that sits in between K and L. And suppose that the order of L over M is D. Since L over K is normal, finite normal, L over M is also normal. So the order of M star is, which is the order of the Galois group of L over M, which is the order of a normal finite normal extension, is still D. Okay. Great. All right, so let's pocket that for a second. If H is a subgroup of G of order D, then when we look at the fixed field, we also proved in chapter 11 that the order of L over the fixed field, or the degree of L over the fixed field, is also D. Okay. So what this is saying is, if we have an intermediate extension of degree D, it corresponds to a subgroup of order D, and if we have a subgroup of order D, then it corresponds to an intermediate extension of degree D. So star and dagger preserve the degree / order. And by what I mean by that is exactly what this is saying. Okay. And if we then compose them, so star then dagger, or dagger then star, this must preserve, all right, let's see. Preserves, if I do star first, I must have gone from an intermediate extension. So this goes from extensions to subgroups. So extensions to subgroups, subgroups back to extensions. So let's see, it makes sense to say that preserves degree. And then the other one goes from subgroups to extensions, and then extensions back to subgroups. Okay, so this one makes sense to say it preserves order. And let's say respectively to indicate. All right. Okay. Now, so what? How does that relate to them being mutually inverse bijections? Well, let's do. Let's see something. So let's compute M asterisk dagger. So what is that? Let's go one by one. So really there's parentheses here. M asterisk is the Galois group of L over M. And then we have to dagger that. All right. So what's the dagger of that? Well, it's the fixed field of the Galois group of L over M. So it's the L's in L such that, let me say sigma of L equals L for all sigma in the Galois group of L over M. Again, I'm just writing out the definition. Everything in the Galois group of L over M fixes M. So we know that M is a subset of M star dagger. But then we have this tower. In fact, I don't even need the K part. We have that tower. And we know that the degree of L over M, well, M star dagger, the composite preserves degree. That's the same as the degree of L over M star dagger. But by the tower law, I should also have an M star dagger over M here. But these guys here are the same. If this was degree D, this one's also degree D. So this other guy must be a 1. So let me write that out. Since Lm equals Lm star dagger, we have that the degree of M star dagger over M is 1, and so they're equal. In an exactly analogous way, if we have a subgroup of the Galois group, let's be a little bit more clear than in the book. For any H in the subgroups of the Galois group, if we were to write out H dagger star, all right, what's H dagger? It's the collections of all L and L such that H of L equals L for all H in H dagger, and then we take star of that. Okay? So what's star of that? Well, let me call this guy just H dagger. This is the Galois group of L over H dagger. Now, what's true here? Well, if H is in H, then, well, H is a subgroup of the Galois group, so H certainly goes from L to L, and H sorry, this should be an H, not H dagger. And H certainly fixes every element of H dagger. Because H dagger is the collection of all things that are fixed by everything in H. So if I have something in H, it fixes everything there. So H is certainly an element here. Okay, but again, so we've shown that H is a subgroup of H dagger star, and this dagger star preserves order. Oops, dagger, let me write it like this. H dagger star is the order of H. So if I have finite groups, one a subgroup of the other, and they have the same order, they must be equal. So H is H dagger star. Great. Okay, so that was a little bit long, but this shows that when you do dagger and then star, you get back H. And this guy shows that when you star and get dagger, you get back M. And the last thing was their order reversing. We've mentioned this before, but just as a quick reminder for why it's order reversing. If we have two intermediate extensions, one contained in the other, then the Galois group of L over M1 is not contained in the Galois group of L over M2 in general, because guys here are the automorphisms of L that fix M1. But just because you fix M1, it does not mean you're going to fix M2. That's not the case, right? I can move M2. I just have to fix the smaller guy. So this is the wrong order. What happens is instead, the guys, I've described it as contravariant. The Galois correspondence is contravariant. So this is our M2 dagger, or M2 star, and this is our M1 star. The elements of the Galois group that fix M2 certainly corresponds to elements of the Galois group that fix M1 because M1 is smaller. So that makes sense to write. And so the inclusion reverses. So M2 moves over on this side and M1 moves over on that side. So that's order reversing, which is a contravariant behavior. And similarly, if H1 is contained in H2 is contained in G, then the guys that correspond to H2 or H1, let's say, is the collection of all L's in L such that H of L equals L for all H in H1, and H2 dagger is a collection of all L's in L such that H of L is L for all H in H2. H2 has more elements in it than H1, so there's more guys here. So if there's more guys, there's more requirements to be fixed by all of them. So this H2 dagger is smaller than H1 dagger because I have to be fixed by more elements, not less elements. Oh, this is a subfield of H1 dagger. So the inclusion got reversed. And so that's that second part of 2. So let's just make sure we got that mutually inverse. Set up. Okay, great. All right, so we'll prove the next 3 guys in the next video.